Hello everyone, welcome to our course Reinforcement Learning. So as part of this course, in this lecture we will discuss about the gymnasium topic, the new topic that is called as gymnasium. Okay, so what mean by the gymnasium? So before going to the to know what mean by the gymnasium, let's check. Suppose you want to teach robot to walk. You want to make a robot how to walk, and you want to teach a robot how to walk. Then where will robot will practice? Where will robot will practice? Do you think we will leave the robot into the playground, or we will make it practice in the playground, or in the crowded places, or in the real-time places? No. So before testing the robot in real world, we usually train it in the simulation environment. We will not train the robot in the laboratory. We will not train the robot in the grounds. We will train the robot in the simulated environment. We will not train the robot in the laboratory. We will not train the robot in the ground, but we will train the robot in the simulated environment. That's it. So before testing the robot in the real world, we usually train it in the simulated environment. Okay. So now, so what is the advantage of training a robot in the simulated environment? The advantages are like your robot may fall 1,000 times, nothing will happen because it is a simulated environment, no damage to anyone. Okay, and it learns from the every mistake, how many mistakes happening in a simulated environment, nothing will be damaged. Moreover, your robot will learn more based on its experience, based on its mistakes. When we go in the real time, we can't allow those many mistakes. It will create a problem to others and it will damage the robot also. So when it comes to the simulated environment, there is no damage, there is no harm to anyone. How many times it will fail, how many times it make mistake, no issue, but it will learn from those mistakes. So it improves continuously. It improves continuously. It will try, it will do mistakes, but it will learn how to walk and improves continuously. So try again without causing any damage. As I said, it will try multiple times. It will try multiple times without causing any damage. Without causing any damage. So that's why we are going to the simulated environment. Now coming to the point, gymnasium. So what mean by the gymnasium? So gymnasium is a open source Python library, or gymnasium is a simulated environment in Python. So gymnasium is a open source Python library that provides standardized simulation environment for developing, testing and comparing reinforcement algorithms. Okay, so gymnasium is a Python library. It is a simulated environment which is used for developing, for testing and comparing various types of the reinforcement learning algorithms. Remember, developing, testing and comparing various types of the reinforcement learning algorithms. We use the gymnasium. It is a open source library in Python. It is a simulated environment in Python. So you can think gymnasium like a student do the practicals in virtual laboratory. Even he made a mistake, nothing will be happen because it is a virtual laboratory, and he gained from that experience, from the work experience, that what he did in the laboratory, virtual laboratory. Let us assume student want to learn one concept, so then he want to implement. So he will do the implementation in the virtual lab. When he did in the virtual laboratory, then if he made a mistakes, he understand what mistake is happening, but nothing will be damaged, no damage will be happening. But he learned what are the combinations of chemicals that can be used to get a separate composition. So he will gain the experience. Based on the experience he will learn. And how we gain the experience? By doing the more practice in the virtual laboratory, by making the more mistakes in the virtual laboratory. If you are real-time laboratory, if he made a more mistake, there is a damage will be happening. But where in the virtual laboratory, even if he made a more mistakes, no problem. But with that mistakes, he understand what to do, what not to do. He will learn. So your gymnasium environment is also like that only. It is a simulated environment. Okay. So why do we need gymnasium? Without gymnasium, what are the problems? With gymnasium, what are the advantages that we will discuss? Suppose without gymnasium, we have to build the environment from the scratch. We have to build the environment from the scratch. If you are not using the gymnasium library, then you have to build your own environment from the scratch. From starting, you have to build it. So then it requires the more effort and also it takes the more time. And it's difficult to compare the different algorithms. It's very difficult to compare the different algorithms when you build an environment on your own. And results are not standardized. Results are not standardized. As I said, it's a time consuming. It requires more effort and it requires more time. And it may lead some errors also when you are building your own environment from the scratch. And coming to the gymnasium part, so it is ready to use environments. All the environments are readily available and use it. And standard interface. And it is a very fair to compare the different algorithms. It is a very fair environments to compare the different algorithms. And easy to integrate with Python and deep learning libraries. It is easy to integrate Python and deep learning libraries. So these are the advantages of gymnasium. Advantages of gymnasium. I hope you're clear. So we have the many environments are available in the gym. So some of the environments are like Cartpole environment and mountain car environment and frozen lake environment and taxi environment and Atari games environment. We have the multiple environments are there. Multiple environments are there in the gymnasium. We will discuss each environment and we will implement as well, and we will create some random agents also. For few environments, not all the environments, there are the tens of environments are available, but we will go with 5 to 6 environments and implementation. So this is about the gymnasium. And coming to the main components in the gymnasium environment, gymnasium environment. So the components are, one is called as the environment. So environment, and it also provides the current state, current position of a agent, and also it will provide the information about which action the agent chosen, and the environment will also enables the environment to execute the new action. Whatever the action the agent chosen, that action will be executed in the environment, by this gym. By the gym, you can execute the action that chosen by the agent in the current environment. So when gym execute the action in an environment, then your agent will be moved to some other new state. Then he will get the new state. Moreover, based on the state and based on the action, he got some reward also. And this process will be repeated. For example, you can see this is an environment. Agent chooses one action. Once agent chooses the action, the environment executes that action. Once the environment executes that action, then the agent will move to some new state. Agent will be moved to the new state. And based on the obtained state and based on the action chosen, the agent will got some reward. He may got reward, he may got penalty also. Okay, so based on this reward and penalty, and in the environment, based on the state, he got the reward or penalty in the environment. And again, from that state, this next state will become a current state, this next state becomes a current state, and from this state, again, agent chooses some new action, and environment executes the action, and it goes to the next state, and he got the reward or penalty, and the next state will become a current state, and from this current state, your agent chooses the action again. So this process will be repeated, and he will learn, the agent will learn based on all these steps. Okay, so environment is a world in which agent lives. Environment is a world in which agent lives or in which agent learn. So it provides the current state to the world. The environment will provide the current state to the agent, and agent chooses the action based on the state, and the environment executes the action, and based on the action, it will go to the new state. Agent go to the new state in the environment, and the agent will receive either reward or penalty based on the new state, based on the action he applied. And this process will be repeated. All these steps will be repeated until episodes or until maximum number of iterations reach. So this is how your reinforcement learning works. So reinforcement, so agent will be in the environment. Agent chooses the action. Environment applied that action. Once environment applied that action, then the agent moved to the new state. When the agent moves to the new state, then based on the state, based on the action, he got either reward and penalty. So now the new state will become a current state for the agent. Again, the agent will choose the new action from that current state, and environment applied that action, and then it moved to the next state and got some rewards. So this process will be repeated until your episodes terminates, until you reach the maximum number of iterations. That's how your agent will learn in an environment using the reinforcement learning. So hope you understand. Okay. Now coming to the one of the environment that is called as a Cartpole. We will discuss about the Cartpole environment now. Cartpole environment. Later we will discuss one by one. We will discuss about the Cartpole environment first, and later we will move to the implementation. Later we will move to the mountain car, frozen lake, taxi. Sequentially we will move. Now coming to the Cartpole. So this is the Cartpole environment, popular gym environment that is called as a Cartpole. In Python, we will call the Cartpole environment like Cartpole v1. So it's the case sensitive, C should be capital, P should be capital. So Cartpole -v1, that's how we will call the Cartpole environment that is available in the gymnasium library. Now, what is the Cartpole environment? So this is the first environment used almost every RL course. That is the first environment that is used almost every environment. Okay, but as of now we are not discussing the any algorithms. Just we will build the random agent in the Cartpole environment, and we will calculate what is the total reward, what is the average returns he is getting, the agent is getting. So coming to the Cartpole environment, so just imagine balancing the broomstick on your hand. So it's like balancing a broomstick on your hand, right? So like that. So this is the, if you move your hand correctly, the stick remains balanced. The stick remains balanced. Okay. If you move incorrectly, the stick may fall. So when this vehicle is moving either right side or left side, then your stick will be fluctuating like this. Left and right, it will be fluctuating. So you have to hold it. You have to maintain that angular velocity and angular position in such a way that the stick will not fall down. The stick will not fall down. So whenever you are able to maintain the stick upright without fall down by balancing the angular velocity and the angular position, then you got the rewards. You can see the timestamp 35, iteration 35. The agent must keep the pole upright by moving the cart either left or right. By moving the cart either left or right, the agent able to keep the stick upright, not fall down. So that is the goal in this environment by the Cartpole. What is the goal? Keep the pole balanced as long as possible. Pole balance means pole should be upright. Pole should be upright, straight. It not fall down. So pole should be balanced. That is the goal in the Cartpole. So what is the reward? What is the reward here? For every step without falling the pole. This is called as a pole. This is called as a pole. Okay. So for every time step, the pole remains balanced without fall down. Then the agent will get the +1 reward. The agent will get the +1 reward. So when this will be closed? So if the pole falls, fall down, then the algorithm will stop. Or cart moves too far. That means it will take the maximum number of iterations. It reaches the maximum number of iterations, maximum episodes, then also it will stop. So what are the termination criteria? Termination criteria, these two are called as the termination criteria. These two are called as the termination criteria. Okay, termination criteria. So what are the termination criteria? If the pole fall down, then the algorithm will stop, the implementation stops. If the cart moves far, that means let us do, if I said episodes equal to 100, that means if you reach the 100 episodes, the cart will stop, the algorithm will stop. So that is the termination criteria. And what are the applications? So this type of environment can be useful in balanced control, because we are balancing the pole by moving the cart up left and right. By moving the cart left and right, we are balancing the pole. So such type of balance control we use the Cartpole environment, and also for the robotics and also for the autonomous systems we can use this Cartpole environment. Okay. So what is the agent here? Here agent is cart. This is the agent actually. This is the agent. Cart is the agent. And what the goal of this cart? Goal of this agent? The cart will move right and left in such a way that the pole should be upright. Pole should be balanced, not fall down. So if the agent, that means cart, able to move forward, backward, without falling the pole down, then he got the rewards. That is his goal. So what are the actions here? The actions are the cart will move, either move right, the cart may move right side, right action, or the cart may move toward the left side, left action. So the cart will be move right or left, so that it will balance the pole. Okay. So that ultimate goal is, the ultimate goal of the agent, ultimate goal of the cart is, it should maintain the pole balanced. If the pole is fall down, that means the episode ends, algorithm terminates. Right? So this is the how Cartpole will work. And I found one small video in the YouTube to visualize how your Cartpole looks like. Just watch it. Later we will move to the implementation part.
The Cartpole problem isn't necessarily a discussion about Q-learning. Rather, it's a discussion on how deep learning can lend a helping hand. In this case, the reinforcement learning algorithm is tasked with keeping a pole on top of the cart upright for as long as it can manage. This seems like a relatively straightforward problem, except for the fact that the boundaries of the variables are extremely large.
So hope you understand how Cartpole looks like and what mean by the Cartpole environment, what are the goal, what is the goal of the Cartpole. So in the Cartpole, the actions are actions. So because the action space, in a reinforcement we have to mention the action space. So action space is move left or move right, that is the action space, and reward is +1 if it is balanced. So if not balanced means it is fall down means your algorithm terminates. Okay. And you have the state also. Actions are, we know, so action space you can, so we know the action space, so what is the action space? That is the left movement and right movement. This is the action space. And similarly we have the state space also. What are the states? States means it will represent the position of your cart, position of your pole. That will represent like angular velocity and angular position. That will represent the state of the pole or state of the cart. So we will discuss more in the Python implementation. Hope you understand what mean by the gymnasium and what mean by the how the Cartpole environment looks like. And in the next lecture we will discuss about the Python implementation in detail. Until then, bye. Thank you.